Welcome, this is Edexcel's M1 June 2003 question 5. This is all a vectors question, okay? We're told that there's an acceleration vector 2I take 3j. I've just written it in column form, because I'm doing the video and other people are the ones sat behind the screen, okay? And we're told that at time t seconds the velocity is v meters per second. Now it's just a bunch of words that they throw in there. Doesn't help you. You could cross it out. I just scribble it all out because it's a load of old tosh, okay? You don't, that's logical, alright? Just, I don't know, it's pointless, okay? It might be giving you a bit of a heads up towards the equation you can use, but anyway, this is a key bit here. When t equals 0, the velocity is minus 2I plus 7j, or in other words, minus 2, 7, okay? Now that's key, okay? Because what it wants us to find out is the value of t when p is moving parallel to the vector I, okay? And there's p is this particle which is associated with this acceleration vector. So this is the acceleration vector of this particle p. Okay, so what the hell does that mean? Find the value of t when p is moving parallel to the vector I. Well, when it's moving parallel to the vector I, okay, remember I is the first one here, okay? When it's moving parallel to the vector I, it is only moving in the I coordinate, if that makes sense. So all the other ones are going to be, so all the other ones are going to be 0, okay? So the value of I, the I coordinate, might be 1, but all the others, I, j and k, will be 0, okay? So that could be a potential parallel to I, in the same way that 2, 0, 0, or 3, 0, 0, okay, them vectors are all parallel to I, okay, because they don't exist in the sense of any other vectors, in any other unit-based vector idea, okay? So what we're going to do now is just take this idea a little bit further, okay? So basically the j vector is 0, because we're only considering 2D here, so therefore the j vector must be 0. But to be able to work out the j part of this vector being equal to 0, we need to come up with the vector equation of a line, okay? Now normally in the vector equation of a line you would do something like line L1 and you would denote it by r equals the position on the line, which could be 2, 3, 7 for example, plus lambda times the direction vector, which might be another set of figures. Okay, but clearly this is not talking about a line, this is talking about motion of a particle, okay? So therefore the only equation, basically we have to look at this is why maybe it's giving us this, the time t seconds, the velocity is v meters per second, so we need an equation that links velocity and time, and well, we've given acceleration, so we're going to have to use that, okay? So the only equation that links v, the time and the velocity, is v equals u plus at. Now you might be going, okay, well why have we got u? We've not got u, okay? Well, we have, because when t is 0, that's the initial velocity. So they might have wrote u, instead of writing this box here, they could have just wrote u is equal to minus 2, 7, okay? But they didn't write that because they'd be giving it away, you know, and they're not that nice, okay? So the velocity at time 0 is minus 2, 7, okay? So you could work it out by just putting it into here, okay? So therefore minus 2, 7 is obviously when t is 0, so that means this a times t must be 0, so therefore v must equal u. So therefore u equals this minus 2, 7. That's kind of proof using the formula that it is the initial velocity. But as I said, obviously you knew that. Okay, so how does this help us answer the question? Well, what we can do is we know the acceleration vector, okay, and we know basically this is the vector equation of this line, this v equals u plus at. Now we know what u is, we can sub what, now this v is now pointless, we've used it up, we know that's u, and we know a, okay? So let's put in what we know into this equation in terms of the vector format of it, okay? So that's the next thing we're going to do, because that allows us to come up with the vector equation of the line. Okay, so hopefully you see that u is at minus 2, 7. Shouldn't have really rubbed that out, never mind. Okay, so we want v equals u plus at, subbing what we know. Okay, well we don't know v, that's the sort of like putting r, okay? U is minus 2, 7, so that's sort of the position on the line sort of thing, plus a, which is our acceleration vector, 2 minus 3 times t. Okay, so if you wanted to make it look more like a vector equation of a line, you could have wrote v minus 2, 7 plus t 2, 3. Okay, it doesn't matter which way around you write it. Okay, doesn't, as I said, as long as it looks like that, you will be okay. But now we know that the as I said, it's parallel to the I part of this coordinate, okay? So therefore, this j coordinate must be 0. So therefore, the j coordinate, the j part of this position vector is 7 take 3 times t, or 7 take 3t. And that is the j vector, which we know equals 0 because it's parallel to the I-axis, okay, or the x-axis, right? So 7 take 3t equals 0, so therefore 7 equals 3t, so therefore t equals 7/3. Okay? So that's the value of t when p is moving parallel to the I-axis. Okay, so that's your answer. Or in other words, you could have wrote, 2 1/3, but you could leave it as 7/3 if you would like. Okay, so that's really the value of t there. Now, using this equation, our next part, we can, obviously all of this here was just for part A, so now we just use this vector equation to help us work out our next part, part B. Okay, so part B says, find the speed of p when t is equal to 3. Okay, so what we do is use that vector equation and sub in t to be 3. Okay, so this is part B. So v equals, and then you do minus 2, 7 plus 2 minus 3 times 3. Okay, so therefore v, if you want to space this out, you can do. I'll write it down for you. So minus 2, 7 plus 3 times 2 minus 3. Okay, so it's 6 minus 9. Add the corresponding like values together, so you get v, the velocity vector, as minus 2 plus 6, which is obviously 4, and 7 plus minus 9, or 7 take 9, which is minus 2. Okay, so you get the velocity vector as 4 minus 2, or 4i take 2j. Okay, so that's your answer for part B. Now, what it's... Oh, sorry, see, not the answer, that's nearly the answer. Okay, so to get the speed, that's all we can do. You might think, that's it, we'll stop, as I almost did just then. But we have to remember, well, what actually is velocity? Well, back in the good old days of AS physics, if you were there, or I think we mentioned it in my in my tutorials for mechanics, which is weirdly enough what this is based on. Velocity is the speed in a given direction. In other words, it's sort of like this. Okay, so you've got a direction vector. Okay, velocity, but because velocity is speed in a given direction, we need to work out actually just the magnitude, okay? We need to work out the scalar of this vector, okay? And to be able to do that, we just simply use our Pythagoras method, okay? Which is 4 squared plus 2 squared, no, never mind, it's negative, okay? So that's obviously 16 plus 4, which gets you obviously root 20, and therefore root 20, so the speed is just 4.47 meters per second. Okay, so that's your answer for part B. Alright, now going to move on to part C now. Find the angle between the vector j and the direction vector of p when t equals 3. Now, what I'm going to do here is I'm just going to tidy this up a little bit, and so basically I'm going to rub this out. So I'm going to do it for once. Okay, so that's obviously the speed, but obviously you get all this bit. Right. Okay, so let's imagine this. Alright, so what we need to do is do a quick sketch. I always say, when you've got a vector question, you always do a sketch. Okay? Sorry, okay, the velocity vector, well, the first thing we draw on is the origin, okay? So we draw on the origin, and remember that is at 0, 0. And then we just have to draw on the velocity vector, which is 4 minus 2, okay? So it's somewhere over there, okay? So 4 minus 2, okay? So it's 4i take 2j, okay? And what we're doing, that the find the angle between the vector j and the direction of motion of p when t equals 3. Okay, so we need the vector j. Now, remember I, j and k, so j is just vertically upwards, okay, from the origin. So it's just 0, 1 or whatever, but we're not considered how far up it is, we're not really bothered about that. It's just the angle, okay, so that's the vector j. And what we need to do is work out this angle here, call it theta. However, we could do the dot product of that, but that'd take a long time, okay? But what's a lot simpler, sorry, you won't know what the dot product is actually. Yeah, you could use the dot product, which is something that you learn in C4, so you could go and check out my tutorial on that. But for M1, what they want you to do here is split this up into a right angle and another angle and add them together. Okay, so obviously this between J and the horizontal one, which would obviously be I, okay, that's 90 degrees. What we're really interested in this other angle, which we're going to call theta 2. Okay, and the right angle we're going to call theta 1. Okay, so theta 1 plus theta 2 equals the total angle that we need to find out. Now this theta 2, well, we need to be able to work that out, we need to consider the lengths. Okay, well, we know this is 4 across and 2 down. Right, so it's 4 across and 2 down. So it's got lengths of 4 and 2, and we want to find out this angle. Now what we could do is use Pythagoras to work out the length of O to V, or you could just do what we did over here and work out it was root 20. But that's going to be quite difficult if you try and put it into some kind of trig equation. It's a lot easier because we've got the adjacent and the opposite to use tan, okay? So therefore this theta, tan theta 2, sorry, is equal to the opposite over the adjacent, so SOHCAHTOA, okay? So it's opposite, which is 2, over the adjacent, which is 4, or tan theta equals a half, so tan inverse both sides, or arctan, it's up to you, okay? So this theta 2 is equal to the tan inverse of a half, okay? And then you get theta 2, and it equals 26.6 degrees, okay? But that's not just the total angle. Remember, we also have to include this right angle that we've just kind of shot off, okay? So we add 90 degrees to that to get the theta that we want to find out, which obviously is therefore 116.6 degrees. I think you'll find that's 116.6666, but I've just left it as 116.6. Or I'm not sure exactly what this rounds to, but you get the idea. We get 116.6 degrees when we answer that question. Okay, so hopefully you get the main idea of that. That's the answer to question 5. So thanks for watching. Hopefully it's been of some help, and we'll see you in question 6. And my voice won't go as weird as it just did then.